Okay, so this is IAT 806 lecture 1.3, bite-sized chunk number 1.3. And what we're going to talk about today is, in this segment, is about programming languages and the processing system that we are going to use throughout this course. So what we're going to learn about is doing programming using a programming language. And we'll talk about the details of how the language works shortly. But in general, what programming languages are abstract, so-called human understandable languages for telling a computer what to do. Now, in truth, people can understand all sorts of languages if they really set their minds to it. But what goes on with programming languages that people use every day is that the abstract human understandable language must be translated into a lower level language, a more detailed and arcane language that is quote unquote understood by the machine. The translation from the abstract human understandable language to the machine language, or the lower level language, is accomplished by an interpreter or a compiler. And those are both technical terms for programs that translate higher level languages into languages understood or interpreted or run by the machine. So we are going to learn the compiled language Java. And in that language Java is going to be wrapped around the system called processing that we'll talk about in a bit. So here is a very simple Java program. This is in fact simpler than a typical Java program because it really is just everything that you see here you can type into the processing system and run. So this you might think of as human understandable. What does that mean? Well, human understandable, human readable, you have to, as you move forward, and you will understand this as you move forward throughout the course, learn what each of these symbols and elements mean. What this thing does is it just prints the numbers 0 through 9 on the screen. And this is what is called a for loop. And what it says is it starts with by initializing an integer variable named I, sets it to 0, and then repeatedly executes the body of this loop and does print line of the value of I. Print line means printing whatever is in between the parentheses and then ending the whatever's printed with a new line so that subsequent prints occur on the next line of the text thing that it's creating. Human readable, of course, as I've already alluded to, is relative. That is to say, this straightforward loop, or for loop as it is called, the Java compiler translates this into the Java virtual machine assembly code that we see here. And this is the actual assembly code that was generated, and as I suggested earlier, it's stripped down and it accesses a bunch of machine technologies to be able to do the activity that is specified in that for loop up above. We won't look at any more of this kind of stuff. I'm just simply showing you the idea of what it is that the Java compiler is doing and translating into machine language. So Java, we're using that because it is an object-oriented language. And object-oriented languages came along a little later in the history of programming languages. One of the earlier styles of doing programming was procedural programming languages. An earlier style still was assembler or machine languages of the kind I just showed on the previous slide, but those are very hard to program. And so procedural languages started to get invented in the mid-1950s, and object-oriented programming languages got invented in the 1980s. So procedural programming languages, an example of which is C, what happens in those is you typically create some data, say representing an image, which would be an array of pixels or picture elements to draw on the screen. You would then write procedures that can be handed the information about what an image is and where it is located in the memory. And then a C procedure will draw the image, say, on the screen, or another procedure would turn the pixels all to green, and another procedure might turn all the pixels all to blue. The idea is that there is a chunk of memory somewhere containing the image, and there are procedures that operate on that chunk of memory. And in fact, you could have a collection of images, and that procedure would act on each of those images bypassing the details of where that image is located. By contrast, object-oriented languages such as Java and many others create a class that contains the image and procedures to draw it and change the colors to green or blue and so on, so that the data and the behavior, the ability to draw in this case, are in one container. The thing that's important about it is that only the object, the class, is able to manipulate the contents of the image. The advantage of doing so is that it provides a single location for a programmer to look as to how it is that an image is manipulated. And this has a big payoff in terms of reducing the overall complexity of programs that are built using object-oriented techniques. It also reduces the kinds of errors that may crop up if, say, for example, in a large C program, some other piece of code that you don't know about is accessing an image and updating it and changing it in ways that weren't anticipated. Object-oriented languages were built to anticipate and prevent that kind of accidental changes of values of the kind that would be permitted in C. Java has some historical relatives. C++, as you might have C and C++ are examples of related programming languages, and the syntax of C and C++ and many other programming languages are all common to each other. That for loop you would recognize from C, from C++, from C#, and from JavaScript and other languages like it. Another Java relative is Smalltalk 80, which was developed in 1980, as the name suggests, by Alan Kay and the Dynabook project at Xerox Palo Alto Research Center, or PARC, as is shown here. We'll talk about Alan Kay later on in the term when we investigate one of his readings where he introduces this concept of Dynabook. So with Java, designers started with C++ and wanted to make it smaller, simpler, and a little bit safer. There's some technologies in C++ that you can use that make it a little bit more easy to make certain types of mistakes. And so the designers of Java wanted to prevent those kinds of mistakes. It was intended to be used industrially, so to speak, and Java is one of the more widely used programming languages, as well as for programming embedded systems, such as toasters, microwave ovens, and things like that, where reliability was very important. And because, once you ship an electronic device, you'd prefer not to have to do updates every year, and so the idea was to build a safe language that enabled that kind of robustness of the system. Java was also introduced at the time when web programming first started, and it was incorporated into web browsers at a critical moment in the mid-1990s. So the way Java works is Java has essentially two stages of interpretation. The first stage is the translation from the programming language that we saw an example of 3 or 4 slides ago with the for loop, and to compile to a so-called virtual machine. And then on an actual machine, the virtual machine instructions, which we showed in that slide, I think 3, is translated into the real machine instructions of an actual machine on an actual computer that you would hold in your hands or would sit on the floor next to you. The concept is that you would write a program once and be able to run it everywhere. So on a PC, you write your Java program, it gets translated into Java virtual machine language, which is then translated by the Java virtual machine into Windows instructions that run on the CPU inside your PC. Same thing on a Mac, same thing on your cell phone. And inside the Java machine is a virtual Java operating system and a virtual machine that is then run on the real machine. All those details don't really matter to you, and at the time that this was first introduced, there was a bigger difference between PCs, Macs, cell phones, and so on and so forth. Over the last number of years, there has been a continuing convergence and improving capability of portability from one hardware platform to another. So this advantage is now fairly common amongst many different systems. So all that's very nice. I was talking about Java, but we are, of course, using processing. Processing is a system that is built on top of Java And more modern versions of processing also enable you to do other programming languages. The purpose of processing is that it starts by enabling script-like coding. And the advantage of it is that it is easy to get simple programs, like that for loop we showed a few slides ago, up fast and running right away. It also allows the transition to full Java programming if you should wish it. And for beginning programming courses like IAT806, it's a great place to start and get the ball rolling, and does something very valuable for a student, and that is to hide unnecessary detail until you really need it. It also has, very importantly for the class, for the course, built-in methods and classes to make drawing easy. And it's also easy to export programs and run them everywhere. So let's talk briefly about how to conduct yourself in the course if you're new to programming. First, to learn how to program, it's necessary to play around with the code. And I'm putting that in red because for some folks who have wished to, who are starting programming, they have some concern that they might break the computer or some other things that might go badly. And my instruction, my suggestion to you very strongly is don't wait for permission. Just go right ahead and start trying to do something in the processing system. And as the way to learn to do programming is to do programming. It's not something that you can read about and then hope to write a perfect program at the start. It just doesn't work that way. It is possible to do that, but it's very, very hard. The easy way to do it is the way we're doing it in the course, which is to get the processing system, get it from processing.org, read code, write code, make mistakes, do stupid things, and do simple things, and work your way up from simple things to complex things. Processing, of course, makes this easy, which is why we're using it. And you can use the reference in the help menu of processing, go to the processing.org reference examples, and you can play with the examples that you find there. Another thing, and this is particularly valuable for those who are completely new to using computers or programming computer systems, you can't break the computer. This is probably advice that is probably unnecessary for all of you, but you can't break a computer with a program you write. Modern computer systems are built to prevent strange things happening. There was a time, 30 or 40 years ago when computers were built without safety precautions of a particular kind, which might have caused little problems to arise. But those days are long gone. You don't have to worry about that. You may write stupid programs, but you can't break the computer. So go ahead and play. Another thing that's very important is that when you want to get started with processing, what you need to do is download Processing 3 on your own machine. And you want to do this for next Tuesday. In fact, do it as soon as you can. Processing, the system, saves all its projects in a directory, in a folder that you can select via preferences. So when you download Processing, you fire it up, set your save folder to something to do with IAT806, and then save the programs that you write. It gives default names, things like Sketch 200908, things like that, it gives you a default name. Once you start writing programs, you do want to give it each of those programs a name that is meaningful to you and to me when we want to grade them. So that's what you'd like to do within the processing system. I mentioned the processing website. Let's just go take a look at that right now. So this is the processing website, and this is what you get when you go to processing.org. And to download processing, you can just simply, hold on one second. You can just click on that download processing, and you're presented with this dialog here. And you can see you can download it for Windows, the 64-bit version of Windows, or the 32-bit version of Windows, Linux, or Mac OS. When you say click on the Windows 64-bit, it's suggesting that you donate some money to them. You don't have to do that, but in essence, you can go and download processing from here, and you can run it on your own computer. So I suggest very strongly that you do that right away, as soon as you can. And then once you run it, you get something that looks like this. So here is the window that is the processing programming environment. In this window, you can see a number of areas. Up top here is the menu bar for the application. I'm running this in Windows, so you can see it here. Above, there would be, usually just above where the cursor is now, there will be, of course, a window title, but the application I'm using to capture this video doesn't present the title area. In any case, there's a number of menus for you to control how processing works and to set its defaults and save files and so on. And there are a couple of buttons here. This is one of the important ones, is you press play in order to run the application. And you can press stop, which stops the application that you've got. The application is essentially the collection of code that you have in this white text area where you enter the program that you want to execute. There's some scroll bars to the right and below if your code gets long. And there's a little error indication area right here in gray. And what I'm going to do is I'm going to move the area up here. And you can see I had already run this little application one time. And you can see that the numbers 0 through 9 have been printed here. And this black area, which is resizable, as you can see, is what's called the console area. That's the area where text can be input and output. There's also an area for errors where it will tell you if there's something that has gone wrong, either when you compile it or when you try to run the program and there's some kind of mistake that you've made. Let me click on console, shrink that back down to sort of its regular minimum size, and I will now press play to run it again. And once it does that, it quickly prints the numbers 0 through 9 in the console area. There they are again. And I can scroll back down there. And it also pops up this drawing area, and I've just clicked on the drawing area. For this program, nothing has been drawn, so you just see the sort of darker gray inset area that is the default 100 by 100 pixel area in which any computer graphics would take place. You can set the size of that to be larger, but at the moment we're just using the standard default size. This is an example of using processing to very quickly start a little program right away. Okay, so that concludes the slides for lecture 1.3.